And welcome back. It's the 31st of May, higher plus 5 a day, and let's just go straight to the first one now. I normally say this, so I'm going to say it now. Last one of the month tends to be a bit harder, but let's see how we go. X to the n equals this thing here. Starting with x to the 0, find x1, 2, and 3. Okay. Now, in an exam, it will probably say to 3 decimal places or something. So I'm not going to assume anything, but I'm just going to do 4 decimal places because that seems sufficient. Start by putting -4 into my memory, and that's going to be my answer. Then I'm going to type in -3 minus fraction button 5 over answer squared. And then I'm just going to press equals. And it gives me a fraction, so I press the equals button, and that tells me minus 3.3125. So x0 is -4, minus 3.3125. Press it again, minus 3.4557. And then press it for a final time, minus 3.4187. And that is the question answered. Yeah, next question. Explain the carrying on. Explain the relationship between the values of x1, x2, and x3 and the equation. I don't know how it wants me to answer this. So I would say x to the n approaches the roots of this equation. I wouldn't do an arrow in my exam. So the roots of this equation as n gets large. Again, it's a bit unclear exactly what it wants to say here. I would hope an exam question might be a bit clearer, but it basically wants you to understand that the two things are linked because the first one is a rearrangement of the second one. Next question. Shown is x squared minus x minus 2. Yes, it is. By drawing an appropriate straight line to graph find estimates for. Okay. Key to this question is I have x squared minus 2x minus 1 is equal to 0 is what I want to solve. I have the line, as in I'm given, x squared minus x minus 2. So if I could rearrange the thing I want to solve to the thing I've got, I could see what the difference is and match them up. So in other words, what do I do to x squared to make it x squared? Well, I leave it as x squared. What do I do to minus 2x to make it minus x? Well, I add x to both sides. Still the same equation, I've just added x to both sides. What do I do to minus 1 to make it minus 2? Well, I take away 1 from both sides, which gives me this here. Crucially, I have the graph of this. So if I graph this, where they meet must be the solutions or the x value of the solutions. So x minus 1 looks something like this. Now in an exam, as neat as you can. The whole point of the question is to be precise. You'll get a very small margin. Actually, I'm even going to zoom in a bit. You'll get a very small margin as to what to do here. I think that is on the line, isn't it? So I'm going to call that 0.4 negative. I'm going to call this one 2.4 positive. So therefore, where they meet, the x values where they meet is your solutions. So therefore, I'm going to say my answers are x equals minus 0.4 or x equals 2.4. Now, obviously in an exam, back of paper where they can't see, double check your answers are correct, but that should be fine. Next one, calculate an estimate for the gradient of the graph, this at the point. Oh, that's a bit annoying. Right, okay, I'm going to get rid of all that. So x equals 1 is here. So I'm going to do my best. In fact, actually, it looks pretty much like this, doesn't it? Now, if you do further maths, do not differentiate. You can check it, but do not differentiate. You need to use the graph. So I'm using the graph. So I have 2 points here. My gradient goes from -3 to 1, which is up 4, and goes from 0 to 4, which is across 4, which means my gradient is 1. And that is question done. Like I say, if you know how to differentiate, do that, but don't let that be the main thing that you do. As in, you need to use a graph. Next question. A money box contains 4 £2 coins. I'm just going to write this here. So 4 times £2, 3 times £1, and 5 times 50p. 3 coins are taken at random. Okay, I know where this is going. Find the probability that exactly £3 is selected. So in other words, how can I get £3? Well, I can get 2 plus a half plus a half, in other words, a 50p, and a half plus 2 plus a half, and a half plus a half plus 2, so the different combinations. Or I could get a pound plus a pound plus a pound. So let's start with the first one. So the £4 half and a half. So there's 4 £2 coins, and there's 12 coins overall, so it's 4 times 4 over 12. Then the next coin is 50p, so there's 5 of those, but there's only 11 coins to choose from. And then the next 50p is there's 4 coins left to choose from, and 10 coins overall to choose from. However, the catch to this question is I need to multiply by 3. And why am I doing that? Well, I'm doing that because it's not just 2, a half, and a half. It's also a half, 2, and a half, and 2, a half. And these all have the same probability. So in other words, I'm doing this times 3 to account for the combinations. Whereas when I'm doing the £1 coins, well, here I'm doing 3 over 12, because any one of the 3, multiplied by 2 over 12, 2 over 11, sorry, times 1 over 10, and there's no combinations. I've got the combinations to account here. Let's add these up. So I'm going to call them A and B, so I'm not squeezing it in. So A is 4 times 5 times 4 times 3, which is 20 times 4, which is 80 times 3, which is 240 over 1320, plus B, which is a bit easier, 3 times 2, which is 6, over 1320, that's B. Add these things together and you get 246 over 1320, which is 41 over 220. Now, I would describe that as a difficult but not too difficult question. Indeed, there have been questions like that on the exam. If you take an GCSE, there's a question like that very recently. So do make sure you're okay with that question. If you're not sure what I've done in the combinations, let me know. But either way, hopefully today went quite well for you. Last day of the month, and I'll see you in June.